A baker claims that the average cupcake sold in his shop has no more than 200 calories. A random sample of 12 cupcakes had an average of 215 calories and a standard deviation of 23 calories. Test the baker's claim using a 5% significance level. You may assume the calorie counts follow a bell-shaped distribution. Okay, so let's start with the baker's claim. He says no more than 200 calories. How would you describe that as a claim with symbols, right? So what we're going to say is then I think the mean, if it's no more than, it means it's less than or equal to, right? Less than or equal to 200. So that's our claim, and that means our null hypothesis and our alternative hypothesis. The mean is less than or equal to 200 would be our null hypothesis, because since that has an equal sign as part of it, right, less than or equal to, it becomes the null. And then the alternative, of course, has to express the opposite idea, so greater than 200 calories. Then the data for this problem, we're going to copy that down. Remember, for hypothesis tests, we always have a sample size, a sample mean, a standard deviation of some sort, and a significance level. All right, so what's the sample size? Only 12 cupcakes, it says. That's small. That's a small sample size. Let's keep that in mind. The sample mean, 215, it says, calories. Standard deviation was 23 calories. And the alpha here is 0.05. The significance level is 0.05. Okay, now we have to form our test stat, but here's the thing. Our test stat here is going to be basically a t-test stat because it has a t-distribution in our class whenever the sample size is under 30. So since n is equal to 12, we're going to go ahead and say, okay, that means that we should plug in the following formula. So x bar here is 215. The value from the claim is 200. Standard deviation is 23. And the square root of n here will be the square root of 12. Okay, let's work that out and see what that gives us. All right, so open parentheses, we'll have 215, then minus 200. Close up the parentheses, divide by open parentheses, 23, divided by the square root of 12. And the answer here becomes 2.259, or you can call it just 2.26, whatever you'd like, it's fine. So I'm going to call it 2.26. Okay, so that's your test stat. And again, nothing really changed, right? I mean, we basically used the same formula. If it had been called z, it would basically look the same. But we have to be very careful about noticing that this sample size is tiny. Because it's less than 30, we're going to go ahead and use this t-distribution to solve the problem. And up to this point, it really hasn't mattered whether we called it t or z. It would be the same. But where it really matters is in the next step when we find the critical value. So I'm going to draw a bell curve. And I'm going to label a 0 in the center and write t here. And then I'm going to look at my alternative hypothesis and see that it's a right-tailed test. So I'll draw a right tail on the curve and say that's my rejection region. So if I fall past this point, if my test stat falls past this point, I'll reject the null hypothesis. But the question is, of course, where does this begin, right? Where does that start? Okay, so in order to figure that out, I need to figure out what alpha is. So alpha in this tail is going to be 0.05. Since it's a one-tailed test, it's all going to be in that tail. And then the one major change here with the t-test compared to the z-test is that for the t-test, I'll need degrees of freedom, which means I just take that n and I subtract 1 from it and end up with 11. So I have 11 as my degrees of freedom. I have 5% in one tail. Let's go to our table and look that up. So area in one tail, 5%, right? And we're going to go down to 11 degrees of freedom, and we get 1.796. All right, so this critical value then is 1.796. And if that's your critical value, then your test stat does indeed land past that point into the rejection region. So we're going to go ahead and say that we reject the null hypothesis. And that means, of course, that we support the alternative hypothesis. And then from there, we just have to decide which one is our claim. Our claim seems to be the null hypothesis. So we're going to say we reject the claim. In other words, we're rejecting the baker's claim. It seems that his cupcakes have a little more than 200 calories in them on average. So we'll just say the sample data allows us to reject the baker's claim.